Three, two, one. Hi, I'm Michael,
I'm Kevin.
and one of our partners, Caleb, couldn't make it here today, but He's here with us in spirit, and this is our Season 84 Final Project Milestone. So for our project, we decided to implement progressive photon mapping, and the idea behind photon mapping is simply shooting a bunch of photons into the scene, seeing how each photon interacts and bounces across each piece in the scenery, and then storing all these bounces within a certain photon map. This photon map could be very naively a vector, or it could be very accelerated, a KD tree. This method is very effective in rendering SDS or caustic paths due to the nature of ray tracers not being able to effectively hit light sources through specular material. So, in order to actually implement this photon mapping, we've had to make a lot of changes and a lot of additions to our Project 3-1 ray tracer. We've implemented naive implementation of K nearest neighbors, hopefully, which will hopefully help us in our KD tree implementation. Okay.
And we also modified Project 3-1. So for example, we added a photon structure, which contains information about the position and direction of photon, as well as an alpha, which weighs the photon. We also modified the sample L function for light sources. So instead of sampling towards a light source, we are now sampling photon emissions from a light source. And we also added methods to basically trace these photons throughout the scene. The image on the right, you can see just the results of tracing 1,000 photons from an area light in CB spheres, and just marking where their first bounce occurred on the scene.
And here are some of the methods that we implemented. Trace photons essentially just follows a photon ray throughout the path it takes and the bounces that occur on it when it interacts with each individual object in the scene. Shoot photons is how we sample the directions from the light that our initial photon rays shoot out. And sample L is just one of the modifications we made to scene lights to have a more expedited sampling of these directions from each light. So that's it for the progress that we've made so far. We hope to include more quality improvements such as final gathering, along with different changes to the weights to improve the spectrum values as they update. And eventually, of course, we'll implement progressive photon mapping once our photon mapper is at a satisfactory position. Thank you for listening.